Now that we're at the end of our gas chapter, and now that we've kind of seen how stoichiometry can play with gases, I think it's important that we take a step back and see how all of these different pieces of stoichiometry can fit together. Now, what you're about to see could actually be one of the most important things you could have in your notes because it really helps you plan almost every single style of stoichiometry problem all at the same time. Now remember that stoichiometry really has a choose your own adventure style to it, that there's multiple ways of converting into moles and that there's multiple ways of converting out of moles. And it all stems from having a beautiful balanced chemical equation with those very, very important state symbols. Here is what I kind of envision as your overall summary of stoichiometry. Your key feature in the center is your mole-to-mole ratio, and you have to kind of weigh what you're given versus what you want at the end. So you can put into stoichiometry now 4 different types of things: solid, liquid, gases that STP, and gases that aren't STP. And if you'll notice, there's actually 4 different ways of converting them into moles. If you have a solid, you have to use a molar mass. If you have a liquid, you have to use a molarity. A gas at STP can use standard molar volume, 22.4 liters to 1 moles. And if the gas is not at STP, you have to do a Pervnert problem before you can go to your mole-to-mole ratio. And notice at the end, your second material, after your mole-to-mole ratio, you would simply do the reverse to get out either a solid, a liquid, a gas at STP, or a gas not at STP. So let's take a look at an example of an equation and how this can work to your advantage. Here's a pretty complicated chemical equation. It's a single replacement reaction between aluminum and hydrochloric acid. It balances beautifully, but take a look at the combination of state symbols in this particular problem. Now that we've taken a step back, we can actually stoich anything we want to in here. So let's go through some hypotheticals. So let's say that the stoichiometry problem gives me everything that I need to know about aluminum, but asks me a question about HCl. So I'm going to take a look at those state symbols, then notice that aluminum is a solid. So the information that I'm given, I'm going to use this first pathway forward using grams over 1 and the molar mass to get to my mole-to-mole ratio. And once I'm there, now I'm in chemical number 2. Chemical number 2 is HCl. It's aqueous, meaning it's a liquid. So I'm going to use this second pathway forward to get back to that chosen unit, usually liters for a liquid, and I would need a molarity of some sort to be able to finish my problem. So let's change the scenario a little bit. Let's say instead of being asked about the HCl, I'm actually asked about the H2 gas. And this is really going to depend on the conditions of the problem. Now, our pathway in the beginning is going to be the same as it was in the beginning, where because the aluminum is a solid, there's really only one pathway forward. But my pathway at the end is going to depend again on the conditions. So if I'm at STP, and now I'm dealing with my hydrogen, I could simply apply the molar volume of 22.4 liters to 1 mole to convert it back to a volume. Or if I'm not at STP, I could follow this alternative pathway using a PV equals nRT problem to convert it back to liters. Let's take another look at another scenario. What if I'm given the information about HCl but asked about Al? So I would start off with my liquid conversion instead. So my liters would go over 1 and I'd have to use its molarity to convert to moles. Once you're in the mole-to-mole ratio, you could apply the molar mass at the end to go back to grams of that solid. Notice how it's all driven by those state symbols. It decides your pathway forward for you. They're really important. How about another scenario? How about I'm given the information about H2 gas and I'm asked the information about aluminum solid. Now again, it depends on the conditions forward. So let's say you start off at STP. So you'd put your liters of that gas over 1 and use standard molar volume of 1 mole to 22.4 liters to convert to moles. And your second chemical, because it's solid, you would use the top pathway forward to convert it back from moles over to your measurement of grams for that solid using the molar mass. Now, what if my gas was not at STP? So I would have to use the bottom pathway to convert that number into moles. Once I'm there, apply your mole to mole ratio, and you can still use the same pathway out of the problem, using the molar mass to convert it back to grams. So I'm hoping that this chart was useful to you. And I'm hoping that you can kind of see that as long as you have a balanced chemical equation and you plan out the information that you're given and asked for in a problem, that there are very few pathways in and out of stoichiometry. But if you keep the information straight in your head, you shouldn't have too terribly much trouble seeing your way forward. Good luck.